Okay, a regular octagon is inscribed inside a circle. The perimeter of the octagon is 96 units. A, what is the measure of the side of the octagon? B, what is the measure of the central angle of the octagon? And C, what is the approximate measure of the apothem of the octagon to the nearest hundredth of the unit? What is, using your answer to part C, what is the approximate area of the octagon to the nearest whole unit squared? Okay, so I'm raising a question here. I'm familiar with a regular octagon is inscribed inside a circle. That's what's been happening with each of these pictures. So that is something I can use as a reference. The measure of the central angle of the octagon, central angle again is right here when you have two radii or vertexes come from the center of your octagon to the vertex of your octagon. That would be a central angle right there. And then the other one is, what is the approximate measure of the apothem? You could use key terms right here. If you see a line segment from the center of a regular polygon to the midpoint of a side of the polygon. So that's pretty much the height. So what the apothem is a line from the center of the polygon right here to the midpoint. So I know this part and this part are the same length. I also know that that's 90 degrees. That makes it the height of this triangle. So we're going to be estimating that height. So we will be working pretty exclusively with these formulas that we created. So if we jump back over here, the perimeter of the octagon is 96 units. So I know if I were to jump here, I could just rewrite this as the perimeter equals 8 times b, because it's a regular octagon, and I'm just going to use this image to help me out. So the perimeter is equal to 8 times b. Well, they said the perimeter was equal to 96 units. To solve for b, since it's being multiplied by 8, we would divide by 8 and divide by 8. And so 96 divided by 8, I can jump over here. That comes out to be 12. So I have 96 divided by 8 is 12 equals 8 divided by 8 is 1. So we have 12 equals 1b. More typically, it is just written as 12 equals b. That 1 is implied. So now I know the value of the base. And then, what is the measure of the side of the octagon? So the side of the octagon, which was represented by b, again remember that that's the value where we found our perimeter from, is 12. So for A, it is 12 units long. What is the measure of the central angle of the octagon? So if we come here and use this as just a reference picture, the central angle of an octagon, how are we going to find that? Well, I know in a whole circle, there's 360 degrees. So I know that if I take 360 degrees and divide it by the number of central angles I have right here in the center, it will tell me the value of each of these individual little central angles. So there's 1, 2, 3, 4, 5, 6, 7, 8 central angles. So I'm going to take 360 and divide it by 8, and that's going to equal the central angle. So if you don't know that off the top of your head, we type in 360 divided by 8, and that's going to give us 45 degrees. So I know that the central angle is equal to 45 degrees. Okay, so for B, on question 9, I am looking for 45 degrees. Now it says, what is the approximate measure of the apothem of the octagon to the nearest hundredth of a unit? Okay, so if we go back to our drawing that we're using as a reference, we can notice that we have this base, which was 12. We have this central angle, which is 45 degrees. So I'm actually going to redraw it over here so you can see it a little bit clearer. So this is 45 degrees right here. And we know that we have this H, the apothem, cuts this to the midpoint. That means that this length is equal to this length. So that means that this is 6 units, and this is 6 units, because this is, again, a total of 12. It's the same length as this. I just know that from the definition of the apothem that we pulled up earlier, that it hits at the midpoint right there. So that means midpoint, it splits it in half, so it's 6 and 6. So now I have a 90-degree angle right here, and I know that the whole angle is 45 degrees. So now we want to find out what the height this apothem is. And I'm looking for the connection to make with this angle right here. And it takes us back to, I'm going to draw this on a different one, because we can find this angle now. So I'm going to draw the central angle somewhere else so it doesn't become super crowded right there. So again, remember, we're looking for this height, the apothem. So in this triangle, we know that this angle is 45 degrees. We also know that this length and this length are radii, so they're the same length. Going back to what we know about triangles and side lengths having the same lengths, we know that the angles opposite them then have to have the same degree measure. So I know that in a triangle we have 360 degrees, and nope, sorry, in a triangle we have 180 degrees. I know this angle right here is 45 degrees, so I'm going to subtract 45 from it. So that leaves me 135 degrees for both of these angles. Because they have to be the same, I'm going to take 135 and divide it by 2. Because they have to be the same, because they're opposite the radii, which is the same. So it says 67.5. So it's 67.5 degrees. So we know that these angles right here are 67.5 degrees. Now, how does that apply to ours? Well, if all of these are all radii, these triangles are congruent. It says 8 congruent triangles. So we know that this angle right here is 67.5 degrees. So I'm going to take this triangle and blow it up. So we have the height for the apothem. We have it meeting at that midpoint, so this length is only 6. We know it intersects at a perpendicular. We know that length is 6. We know that this is 67.5 degrees. And we're looking for H. So this goes back to how do you solve for side lengths on right triangles. And it is going to go back to a trig function, because we don't have the value of the radius, so we don't have 2 of the sides to use the Pythagorean theorem. So according to our viewpoint, our angle that we have, this is going to be our viewpoint because it's the angle we have. So the side opposite it would be H. The side length opposite the 90 degrees would be our radius, which would be the hypotenuse. And this side length that's not the hypotenuse but is touching the angle is the adjacent side length. So then I'm going back to my mnemonic device for the trig functions, so, ka, and toa. So sine has opposite divided by hypotenuse. Well, I want to find the opposite, but I don't have the hypotenuse value, so I can't use sine. Ca is the adjacent divided by the hypotenuse. Well, I have the adjacent. I'm not looking to find the hypotenuse, so I'm not going to even use that one. And then TOA is tangent of the angle is equal to the opposite divided by the adjacent. Well, I want to find the opposite, so that's good. And I have the adjacent value. So we are going to be using tangent. So we have tangent of 67.5 degrees is equal to, I'm going to write this out, h divided by 6. Since h is being divided by 6, I know the inverse operation would be to multiply by 6, so it will reduce down to a 1 on that side. So this side I would have 6 tangent of 67.5 degrees is equal to, well, 6 divided by 6 right there, reduced down to 1, so we would have 1h, which is more typically just written as h because the 1 is implied. So then we're going to jump over to our calculator, and it'll be 6 times tangent of 67.5 degrees. Oops. 67.5 in parentheses. So then notice it is solving for 67.5 degrees, and it gives us 14.48. So the height is about 14.48. And that's equal to the height. So when we jump back over here, it says to the nearest hundredth of the unit. I better check and make sure that, okay, this 5 means that it would round that 8 up to a 9. So it would be 14.49. So then for C, we would have 14.49 units for the height of the octagon. And then now the last question, using your answer to part D, what is the approximate area of the octagon to the nearest whole unit squared? Okay, well remember the area of the octagon is the perimeter, which was 96, times the height, which we found out to be 14.49, divided by 2. So I'm going to jump over again to Symbol Lab. 96 times 14.49 divided by 2, and that gives us 695.52. It says to the nearest whole unit, so this 5 would round it up, so 69.5 is closer to 696 than it is to 695. So this 5 in the tens place rounds this 5 up to a 6. So we're looking for 696 units squared. And that's how I'd go through and answer this question.